Guys, today we're going to be doing an example in chapter 11, a more advanced chapter. But it's going to be a strange example in that it's a little bit of trial and error. I'm going to go to chapter 11, spreadsheet modeling and analysis, question 10. Let's click on that. And again, like always, a couple of tricks along the way that I picked up by trial and error, but try to save you that aggravation. Okay, so here is the Excel file that gives you basic idea of the problem. Each problem is going to have different returns, different maximums and minimums, different risk factors, but they're going to follow the same format. So, for example, we have four possible investments, and we have a certain amount of money that will change from example to example. And if you multiply the percentage by the amount invested in each of these things, 5% times 5,000, 7% times, you'll get the expected return by the formula, the sum of the products, and likewise the risk. We have the portfolio manager doesn't want to have too much risk, so they limit it to 1 point per dollar. So it comes out to 100,000. And negative numbers meaning that it's not that risky. And the higher numbers, like stocks, have a higher risk. But in our example, the numbers are specifically, these are the actual numbers. Let's convert it to an Excel file with with one trick. These numbers here are just taken from the text of the example. So if you check the format, it's not going to be a percentage, it's going to be general. So you want to convert it to a percentage so the computer can use those actual numbers, not just text. Now they're percentages. Now you can take this piece here, copy it, and bring it to the spreadsheet that we were given in general. And these are the relevant numbers, I believe. And you can copy it into this box here, paste, and we have that amount there. Except this particular example, we're given $200,000 to work with, and the limit is also one unit per dollar, so it's 200,000 points of risk. Okay, this is where I've been getting a problem. Let's go back here and see if this is in fact percentages. Let's see the format. It's supposed to be percentages. Here's percentages. Okay. All right, back to the drawing boards. So I don't know if you noticed, but I had to stop for a few minutes because I was getting strange results. Let's try it again. We have a file of the general model, which is right here. But this doesn't include the current values for the example. So instead of retyping each number, you can download the relevant numbers. Do right here. Right here. Change it into an Excel file. You know what? Let's try something else. Let's open up, copy to clipboard. Let's see what happens now. Done, done. Let's open up the Excel file and copy it from the clipboard. Paste. Doesn't let us. Okay, so that experiment didn't work. Let's go back to the problem. Let's copy the data into Excel. Should have realized that. Open it up. These are the relevant numbers. You'll see that column B, those percentages, which was giving me a hard time, has to be modified. Put it here, paste, and now we have the relevant numbers. Except if you notice the total expected return. Now, again, I might have said this before, that the risk factor is done by multiplying the risk factor by the amount invested. So minus 0.5 times 5,000, 1.9 times this, etc. And that's done by the sum product formula. But the same logic applies to this percentage of return times $5,000 and 8% times $50,000, 12% times this should give you this number, but it's zeros. And after quite a bit of trial and error, I realized that there's a problem with these numbers here. We have to rewrite them because they were copied from the text. So it's 0.04 is 4%. 0.04. And this is 8% will be 0.08. Sorry, I couldn't come up with a better way of 12% is 0.12. And 3.5% is 0.035. Now the computer can multiply 0.04 times this amount, so the sum product is working. You might want to change this now into a percentage. Go format cells, percentage equals, and we have it as a percentage. All right, anyway, that's just a technical problem which I had when I copied over from one Excel file to the other. Now get rid of the other Excel file. Where is it? Okay, so the question is, how do we allocate it? I'm going to do this simultaneously with the book's suggestions. So the book says, enter the total amount available in B10, which was 200,000. Check answer. Let's put it into our Excel file. Might as well change this at the same time. This is $200,000. And this amount invested has a minimum of 5,000, so we have to put a 5,000 here, a minimum of 60,000, so we have to put at least a 60,000 invested in this part of the portfolio, and a minimum of 30,000 for stocks. This changes to 30,000. And the savings is the remainder, but the remainder is going to be 200,000 minus these three things here. So instead of having to calculate it, let's just put it as a equals B10 minus the sum of B16, 17, and 18 minus the sum of B16, 17, and 18. Left out a parenthesis. So by definition, this will add up to 200,000. 95, right, it does. And so since this adds up to 200,000, the risk limit, I'm sorry, the amount invested is 200,000. The total risk will be this times this, 60,000 times 1.9, etc. And the expected return is now up to this point. But we have one more risk we could allocate. So this is not going to give us the optimal solution. So let's go back to the problem. This was a 200,000, we said. Check answer. So far, so good. Enter the amount of risk and sell. We did that. Continue. You have to put in the minimums. They tell us to put in life insurance minimum. And we did this. The minimum was 5,000. Minimum here is 60,000. Minimum here is 30,000. The savings account has to be the remainder, which we just said was 105,000. Once you put in the minimums, this is constrained. And so far, so good. Total weighted risk so far is 156,500. And the total expected return is, according to our spreadsheet, 12,275. Check answer. Okay. Now, this solution can be improved. The answer is yes, because we still don't have risk of 200,000. Check answer. Okay. Next. Since life insurance has a better return, invest the maximum possible in life insurance, the minimum in stocks and bonds. What's the maximum? $10,000. 10,000. 10,000 is the maximum. Again, follow the instructions. This is the better return and a better risk factor. So it's best to maximum. The minimum possible in bonds and everything and mutual funds. The minimum we said was 6,000, 60,000, and 30,000. And by default, let's implement that on the spreadsheet. Maximum was 10,000. The minimum was 60,000 and 30,000. Now we're down to 100,000 here. This is going to be 100,000. Check answer. Yes. So far we're up to total weighted risk of 155. And the return on these combination of investments, 12,300. Check answer. Or so good. The weighted risk still less than 200,000. So move money. So here what would your best way of improving the solution? Here, money move from bonds and stocks to the savings account. No, that's going to give us lower risk. Savings account to stocks and bond, that will increase the rate of return. Move money from life insurance to stock, no, that will decrease. No. So I think in order to, we're still short of a lot of risk, so we can increase the risk by moving money from savings account to stock funds. And we got it right. Now, they're going to give you a little equation in a couple of minutes that will help you figure out the next part of the allocation. They do it in 3 steps. First, figure out how much more we have to move to find the best amount to move to stock funds. Or we're going to move it, but how much we're going to move? Well, we have 200,000 to invest. 10,000 is in life insurance. 60,000 is in bonds. So we have a maximum of $30,000. 130,000, sorry. To move. Okay, next. How much extra risk do we have? Here, I'm getting lost. They find the amount of risk left after investing the maximum in life insurance and the minimum and bond total funds. So if we pick the maximums, for life insurance and bonds and 0 for the others, which is going to be a problem, I think. You have 109,000 of risk, which means we have 91 more left over. What did I just say? 109. Okay, here comes the mathematics. So if we have 109 and we have 91,000 risk points left over, and that suggests the following equation. And here's where we're going to take some explanation, where it's hard to do without writing. If you multiply X is the amount we've decided above here, we're going to move the money from savings to stocks. We're going to move the money from stocks, from savings to stocks. The question is how much? Okay, right now. So we have 91,000. We have 91,000 points of risk we have to allocate left over. And it's going to be either equation B or equation D. And the amount that we're investing in stocks has a 2.2 risk factor. So for each dollar we invest, you got to multiply by 2.2. But the other thing, and we have $130,000 to use. So $130,000 is going to go to the savings minus the amount that's going to stocks. So that difference multiplied by 0.2 will give you the amount. Again, it's minus because the risk factor is minus 0.2. So when you multiply it, you will then solve that equation to figure out the optimal amount to move into stocks, but satisfying the amount of risk can only equal to 91,000. So I'm going to guess the answer is D. And solving the equation, they help you. They combine terms for you. Essentially, the way you solve this equation, for those of you who might have forgotten this, is you take the 91,000 and you add to it the minus 26 from the other side, so it's plus 26,000, and you divide by 2.4, and that comes out to 48,750. So that means in English is if we move 48,750, we'll end up with again, X refers to the amount invested in stocks, multiplied by 2.4, by 2.2, the risk factor, etc., and we're good. So it's telling us do that. Now, by definition, this is going to add up to 200,000, and it's going to give us a maximum risk of 200,000. So we can put those numbers into our portfolio, 48,750. Put that here. 48,750. We got rid of that something. So 81,250. And now we should have $200,000 invested, $200,000 of risk. So it's 13,893.75. Now we have 200. That had to be because of the equation. This comes out of 13,893.75, 893.75, and wow, hard to believe I got it right. I did this 25 times. Okay, now they want you to do one last step to check that this is actually the best solution. So since we sort of did this by trial and error, we have no idea this is the best solution. They tell you try a different solution and see if it's better or worse. Doesn't prove anything. If you read the total weight, they said make these numbers 50,000 and 80,000. Now this won't be necessary for the answer because the answer only requires to type in the optimal solution. So this step is really, so to speak, extra. They want you to put in, what did I just say? 50 and 80. Make this 50,000, make this 80,000. And we did it so that it still adds up to 200,000, but the risk is too high. So even though this is a higher expected return, we violated the maximum of 200,000. So our original numbers were the optimal solution. So let's put them into 10,060, I'm sorry, 10,000, 60, 10,000. Oh, guess we have to type this in too. This risk was 203,000. Was it 203,000? Expected return, I think we said was 14,000. Great. Check answer. And correct, but it approves maximum. Continue. So now we have the final answer.
Resume Amazon Music.
Alexa, stop. So let's copy over the numbers. I don't know why we can't copy them. We have the solution was 10,000, 60,000, 48, 750, 81, 250. Close. I'm going to show completed. And this didn't work. But that's because our original example was with 10,000. Anyway, that was correct. Let's stop sharing. Let's stop recording. Let's get out of here. Record. Get out of here. That was great.